So how is the industry addressing the problem? First of all, a lot more money is being invested than ever before. The 2009, $7 billion was allocated for energy storage. I think about $4.5 billion of that was allocated specifically for the smart grid. Unprecedented in our country. I was here for the China discussion. Compared to China, it's a drop in a bucket. Secondly, there are joint ventures being used to leverage technology providers and customers. So, for example, Toyota and Panasonic got together, invested billions of dollars, and that's how they brought the Prius, the nickel metal hydride battery used in the Prius, how they brought that to market. Nissan did the same thing with NEC. They developed the lithium-ion battery. Again, billions of dollars invested. So these really close partnerships tend to take time out of the development cycle and also pool resources and cost together. Samsung and Bosch have done the same thing with lithium-ion batteries. Next, there's venture-backed companies. A lot of venture-backed companies in the materials area, and these companies are partnering with other larger battery companies to provide technology into the slower-moving battery companies. So you have a company like Axion Technology in the UK. They're doing advanced lead-acid, carbon-based lead-acid. They've partnered with Exide, one of the premier big lead-acid companies. So those kinds of technology partnerships are also accelerating. And then also you have companies that are strictly in the business to develop methodologies for high throughput processing. So you have a company here in San Diego, Wildcat Discovery. They can create 1,500 battery-related materials a week, test them, and then figure out which ones have the desired attributes. And there's a number of companies like that, both in the US and in China. And then lastly, one of the things that takes a long time in the battery business is to test and qualify the batteries. And so there are methodologies that you can accelerate the life and the testing of batteries. Temperature is commonly used, and companies like us and others have very proprietary ways. And also the car companies have very, very proprietary ways. They've invested millions of dollars in these secret test regimes that in 1 year can do the testing that would normally take 2 or 3 years. So the prognosis, essentially, energy storage, in my view, is never going to follow Moore's law. A lot of debate, but one metric that's been thrown out there is that every 5 years the performance might double. I don't know if that's optimistic or pessimistic, but that's something that we hear quite frequently. This is going to be controversial, but it's my view, actually, that for large batteries, advanced batteries, that the United States will not be the dominant player. And there's a number of reasons for this. One of the things that was mentioned in the last presentation, which I wholeheartedly agree with, is capital costs. And when you talk about capital costs, you're talking about manufacturing facilities, manufacturing technology. And the fact of the matter is that Korea and Japan have probably a 10-year head start compared to the United States because of sustained government-directed investment over the last 20 years that, $10 billion from Washington isn't going to turn that. China is much farther behind, but the pace of their development is staggering. And we're actually a company where we have we have all of our technology development and product development in China, along with manufacturing. But the advantages that we get in being in China, as was stated previously, are not so much supply chain oriented, cheaper labor for building product, although that's true, but it's mostly on the development and the technology side. So China's pretty far behind right now, but they're moving at 100 miles an hour, much faster than any other country. So I would expect in some number of years China to probably overtake Japan and Korea. And then lastly, it's my belief that taking existing technologies and making incremental improvements to existing technologies. For example, there's many different, I call them flavors of lithium ion. And those flavors will produce incremental improvements over the coming years. But to get to those tipping points, I think that there's new technologies that will be required, not just enhancements of what we already have. Again, these are personal opinions. And so that is, there were actually a couple of charts that weren't, that somehow got deleted. I'm not sure why or how, but at any rate, so that's my presentation. I'd love to have a discussion. Yeah?
What role